Hey everybody, this is your professor. I'm Mr. Blue Pen, and I'm here with Miss Red. Show us Miss Red. And we're doing problem 5 from week 6, but with different numbers. Now, Miss Red, what does this problem remind you of?
It looks like a Menelaus.
A little louder. Menelaus?
Yes, it looks like Menelaus.
What makes it look like Menelaus?
You have the triangle, and then there's this line that's
Cuts through
three
all
collinear
three
points
sides. Yeah.
on three sides.
So these 3 points, B, D, and F, one is on each side of triangle A, E, C. And they are collinear if and only if from A to B, B to C, C to D, D to E, E to F, F to A is equal to 1. Menelaus' theorem, right there. Look at that. Now, all the numbers are written in except for C, D, and D, E. We have 2 unknowns. Well, that's weird. I have one equation with 2 unknowns. That means there's got to be another equation available.
Right.
Okay? So that's one equation. Let me make a little sidebar over here. Is there anything else that applies that would also apply to the problem from week 5?
Oh, it's a right triangle, so
Yes.
I'm thinking that that's going to mean we need to do something with the Pythagorean theorem.
Yes, and if, oops, help me out, Miss Red. Let me keep this in the picture. All right, so here's what we got. We have that 8 squared plus 15 squared is equal to CE squared. Can you dig it? We just got to get it all in the picture here.
Okay.
Does that look right?
Yes.
The hypotenuse is CE. This is not a prime, that's a 1. That's the length of EF. All right. Gonna try and keep everything on the screen so that our people can read it. Okay, well look, CE is CD plus DE. So if we solve this, and it works out, I happen to be a genius. It's 17. CE is 17. Isn't that nice? You know you're doing the right thing when you get a number like that. So that means that CD plus DE equals 17. So that means I can rewrite CD is equal to 17 minus DE. And if I just let DE be X, just to write one less thing, then I can write 17 minus X right there. And I can write X right there. And I have one equation with one unknown. Because what's AB? You tell me.
AB is the...
write it down, Miss Red.
AB is...
Above the AB.
15.
No, AB is not 15.
Oh, AB is 10.
Make it look really easy to read because this is for the world. Good.
B to C is 5.
Miss Red strikes again. EF.
EF.
Let me do EF. It's 1.
And then FA.
You can do FA.
Is 9.
Nope. Oh, you're right. Oh!
Whoa.
Oh, good catch. Oh my God, why are you paying me? I should be paying you.
Okay, that makes it a lot clearer.
Now I've got one. See, the problem didn't say, hey, use Pythagorean theorem. The problem didn't say use Menelaus theorem.
No.
But it's geometry class. You know,
so
all these things are possible. You know, you can do this kind of thing. So let's solve this. I'm going to multiply through the top. So it's just 10 times 17 minus x. That's 170 minus 10x. The downstairs is going to be 45x. And this is still equal to 1. What do we do now, Miss Red?
You want to cross multiply?
I'd cross multiply because then you don't have fractions anymore. Yep. So I've got 170 minus 10x equals 45x. Now let's just stop. Let's stop right here. On the wiki, and this is a Monday. You and I are talking to each other on Monday. On the wiki, somebody tried this problem and got a square root of 97. And I wrote, I know that CE is a rational number. And here's how I know. CD and DE are in a proportion with all these other numbers.
Yeah.
And I can rewrite it in terms of one thing. This is in terms of DE being X. DE has to be a rational number because you're not going to get a square root in this spot and now no square root in this spot.
Right.
So if they're all whole numbers and fractions, then I'm going to get a rational number. X is going to be a fraction.
Yeah,
and that's going to make CD also a fraction because I've got DE as a fraction. So I knew that ahead of time because I knew it was a Menelaus problem with a Pythagorean problem with an integer answer. See, if CE had been a square root, both of these would have square roots in them. But CE on the wiki problem on week 6, problem 5, the hypotenuse is also an integer. I'm not going to say what that integer is.
No.
That's
a surprise.
Mum's the word there. Now, how do we finish this off?
So we would need to move over the 10x. We'd add it.
So I got 170 equals 55x, and so x is equal to 170 divided by 55. We can cancel a 5, but not an 11. So canceling a 5, we've got a 3/4 over 11. That's the best you can do. But that's 34 over 11 for DE. And so CD, that's DE. CD has to be the hypotenuse, 17, minus 34 over 11. And I'm going to stop there. You know, if this was to hand in, I would finish that equation. But it all fits on the page there, and that's sort of readable. And that's 5 points.
Yeah.
And how long did that take? According to my watch here, it's 6 minutes. 6 minutes for 5 points is pretty darn good, because that means you could be done for the week in 12 minutes if you could find another 6-minute problem.
I think the step that I was missing is that you could plug in the you could make one of them a variable CD minus DE. I didn't think about taking that trick step.
When you're looking at two variables, x and y, let's just say, you have one equation with x and y, then you need to find another piece of information about either of them or both.
To knock one out.
And it's really funny to think that we've got x plus y here. You just don't think like that. You know, as soon as you label this with an x and that with a y, you're looking for something else with x or something else with y, and you forget that, well, the whole hypotenuse is
something
available.
that we know.
Yeah. So, you know, don't be shackled to a variable. Just because you wrote a variable doesn't mean that you are stuck with that for the rest of your life. You got to be a little bit more adaptable in case you chose unwisely. Any other comments to make?
No, we're good.
All right, we're going to stop this video and